Welcome all of you dear students in our most popular, most favorite, most famous YouTube channel Physics Make It Simple by Dr. Rajendra Kobarne. Now I have been promoted as a principal by Lokanete Dr. Balasaheb Vikhe Patil Padma Bhushan Awardee, Pravara Rural Education Society, Pravara Nagar at Mahatma Phule Vidyalaya and Junior College, Dad Budruk Taluka, Rahata District, Ahmednagar. We are discussing the chapter Oscillations as long as 12th science is considered, and in the last lecture we have learned the article phase in SHM in lecture number 6. In this lecture, in lecture number 7, we are going to discuss another interesting and funny article that I have already written on the board. Name of the article is Graphical Representation of SHM. And out of that, our first case today we are going to discuss, that is when particle starts from mean position. Listen carefully. Many of the students are worried how to prepare this table, and from the table how to draw a graph and how to make conclusions from the graph. Very interesting, very easy, very funny. Let us see one by one. When the particle starts from mean position, at that time we know initial phase angle phi is equal to 0. Remember well, this is the first condition. When particle starts from mean position, initial phase angle we call it as epoch, which is equal to 0. Initial phase angle phi is equal to 0. I will write on the board. Here initial phase angle phi is equal to 0 degree. So now write the general equation of displacement of SHM. We know equation of displacement of SHM, x is equal to capital A sine of omega t plus phi. This is the displacement of SHM. Displacement of SHM is denoted by x, remember well, which is equal to capital A. Capital A stands for amplitude, while small a stands for acceleration regarding SHM. Very interesting, very important thing. Capital A is used to denote amplitude of SHM, while small a is used to denote acceleration in SHM. Okay, so this is capital A. Capital A is nothing but the amplitude of SHM. So we know this equation. This is the equation of displacement x, which is equal to capital A sine omega t plus phi. Okay. But we know when the particle starts from mean position, that I have already written, initial phase angle phi is equal to 0 degree. So when we put 0 here instead of phi, then what equation will come? The equation will come like this. See here, x is equal to capital A sine of omega t. This is equation number 1. This is equation number 1. We get equation of displacement, dear student. Remember well. Then from this equation, we have to find the equation of velocity of SHM. Take derivative of x with respect to t, we get velocity. Velocity is denoted by v. So we get what here? Capital V is equal to dx by dt. Or we can say d by dt of x. Take a derivative of this. Capital A is constant. Derivative of sin omega t is what? Omega cos omega t. Derivative of sin omega t is cos omega t, and again derivative of omega t is omega. So we get here a omega cos omega t. This is equation number 2. So in this way we get equation of velocity of SHM. Now acceleration. I have already told you that acceleration is denoted by small a and amplitude is denoted by capital A. Remember this thing. So here amplitude is denoted by capital A. Now we have to calculate acceleration. We have to write the formula of acceleration. Take derivative of velocity now. So we get what here? Acceleration A is equal to, take derivative of velocity with respect to time. We get what? dv by dt, or this may be written as like this, d2x by dt square, or sometimes this may pronounce d square x by dt square or d2x by dt square. Take derivative again, derivative of velocity with respect to time. A omega is constant, write down a omega like this. What is derivative of cos omega t? Derivative of cos omega t is minus sin omega t, and again derivative of omega t is omega, like this. Cos omega t, a omega is constant, that I have written here, a omega, it is constant term. Derivative of cos omega t is minus sin omega t, again derivative of omega t with respect to t is omega. So we get minus omega sin omega t. Then omega and this omega, we get what? A is equal to minus, this minus sign come outside, a omega into omega, omega square sin omega t. This is equation number 3. So in this way we find 3 equations, that is displacement x, velocity v, dear students, and acceleration is denoted by small a. These are the 3 equations we will have to derive at first. Okay. Then we have to prepare a table. How this will be remembered? This is displacement, velocity and acceleration. 0, pi by 2, pi, 3 pi by 2, 2 pi, 2 pi by 5 pi by 2, 3 pi. How we can remember this? See here. So I have written a hint here. Omega t stands for n pi by 2. Omega t stands for n pi by 2, where n is equal to 0. Put 0 here. 0 pi by 2. We get 0. Then put 1. 1 pi by 2. We get pi by 2. Then 2. Put 2 here. 2 pi by 2. We get pi. 2 pi by 2. 3 pi by 2. 4 pi by 2. We get 2 pi. 5 pi by 2. 6 pi by 2. We get 3 pi. So in this way, by remembering n pi by 2, we can write a chain of omega t. 0, pi by 2, pi, 3 pi by 2, 2 pi, 5 pi by 2, 3 pi. Very simple. How we remember this? So this can be remembered, this can be written without any difficulty by remembering the formula. Omega t stands for n pi by 2, where n is equal to 0, 1, 2, 3, 4 and so on. Put n is equal to 0, 0 pi by 2, 0, 1 pi by 2, pi by 2, 2 pi by 2, 2 get cancelled, pi, 3 pi by 2, 4 pi by 2, we get 2 pi, 4 upon 2, 4 pi by 2, 2 pi, 5 pi by 2, 6 pi by 2, we get 3 pi. So in this way we have written this chain. Then what is the time factor? Time factor is written by remembering the formula. T stands for n t by 4, n t by 4, where n is equal to 0, 1, 2, 3, 4. 0 t by 4, we get 0. 1 t by 4, we get t by 4. 2 t by 4, we get t by 2. 3 t by 4, 4 t by 4, 4 t by 4, 4 t by 4, 4 get cancelled, we will get t. 5 t by 4, 6 t by 4, we get 3 t by 2. So in this way these two chains these two horizontal lines we can easily return by remembering this formula. Now we have to find the values of displacement, velocity and acceleration by considering omega t is equal to 0. See here now, very simple. What is the formula of displacement? X is equal to, see here, x is equal to capital A sin omega t. Put omega t is equal to 0 here. Put omega t is equal to 0. Put omega t is equal to 0. Sin 0 is equal to 0. 0 into A is equal to 0. So we get displacement is equal to 0 like this. Then next one what? Pi by 2. Put omega t is equal to pi by 2 here. Put omega t is equal to pi by 2. See here, sin of pi by 2. Sin of pi by 2 is equal to 1. 1 into A. We get plus A like this. Then again, put omega t is equal to pi. When sin pi is equal to 0, 0 into A is equal to 0, we get x is equal to 0. Then put 3 pi by 2. Omega t is equal to 3 pi by 2. When there is a odd multiple of pi by 2, sin 3 pi by 2 is equal to minus 1. Minus 1 into A, we get minus A. See here. Now it is not necessary to put another values. How we can write here? See here, 0 plus A, 0 minus A. It may be 0 now, then plus A and then minus A. We can easily return by remembering this 0 A 0 minus A 0 A, not minus A here, we get 0 here. See here, 0 A 0 minus A 0 A 0 like this. So in this way we got the values of x, values of omega t regarding x, values of x by putting omega t is equal to 0, pi by 2, pi, 3 pi by 2, 2 pi serially like this. Then see the equation of velocity. What is equation of velocity? Let me clean the board at first, then write down the formula of velocity. What is the formula of velocity? Equation number 2. V is equal to A omega cos of omega t. Put the values of omega t. Omega t is equal to 0 at first. Put 0 here. Cos 0 is equal to 1. 1 into A omega. We get A omega. We get A omega. Then definitely here we get 0. Here we get minus A omega. Then we get 0 here. Then we get A omega. We get 0 here. Minus A omega. Like this. Definitely we get such a type of chain. A omega comes here, then 0, then minus A omega, 0, plus A omega, 0, minus A omega. These are the values of velocity at different values of omega t as shown in the figure, as shown in the table. In this way we have to prepare a table. Now let us approach regarding acceleration. See here, acceleration. What is the formula of acceleration? We know the acceleration is always denoted by small a and amplitude is always denoted by capital A. Remember this thing. So what is acceleration? Acceleration A is equal to minus A omega square sin omega t. Okay. So A is equal to minus A omega square sin of, what is omega t? Omega t is equal to 0. Omega t is equal to 0. Sin 0 is equal to 0. 0 into all, we get 0 here. Then put omega t is equal to pi by 2. Put pi by 2 here, pi by 2 here, pi by 2 here. Then see here, sin of pi by 2 is equal to 1. 1 into minus A omega square, we get what? Minus A omega square. Definitely here is 0. Then plus A omega square. Definitely now we get 0 here. Then minus A omega square like this. Then here 0. So in this way, this is a chain. If we remember first two values, you can easily write another values. we get 0 here, then minus a omega square, then 0, plus a omega square, then 0, minus a omega square, then 0. In this way, we have to prepare a table of displacement, velocity and acceleration very easily, very confidently. Let us see the formulae. Let us see the observation table. And from this observation table, now we have to draw a graph. How we can draw a graph? Displacement. When omega t is equal to 0, displacement is 0. When omega t is equal to 0, displacement is 0. We get here. This is the point. Then next one. When omega t is equal to pi by 2, we get displacement plus a. When omega t is equal to pi by 2, see here, displacement we get plus a. We have already written maximum displacement plus a and minus a. Maximum velocity plus a omega minus a omega. Maximum acceleration plus a omega square minus a omega square. Remember well that capital A is amplitude. Come here. When x, the value of x is equal to 0 at the value of pi. Where is pi? Here is pi. The point is here. Then at the time of 3 pi by 2, displacement is minus a. The point will come here. Definitely the graph is like this. The another point definitely come here like this. Another point definitely come here. Another point definitely come here. And the graph we get is like this. See the graph. See the graph. The graph we got like this. Okay. This is a graph. This is a graph of displacement time curve. Now let us see velocity. See velocity. At omega t is equal to 0, velocity is a omega. Where is omega t? Omega t is 0, velocity is a omega. Here. We get point here. Then omega t is equal to pi by 2, we get velocity 0. Pi by 2, velocity 0 here. The next point. Omega t is equal to pi, velocity is minus a omega. I will change the pen color. See here. Okay, color of pen now. See here. Then at the time of pi, velocity is minus a omega. At the time of pi, velocity is minus a omega. We get here. Then next one. At the time of 3 pi by 2, velocity is again 0 like this. So we get point like this. See here. Like this. The next point definitely will come like this. The next point is here. The another point is here. And the graph we got is like this. See here. From this. The graph we got is like this. See here. Very interesting, very funny, very easy like this. See, this is a graph of velocity. This is a graph of velocity. Now we will change the pen. We will change the pen color. Now the acceleration. See here. At omega t is equal to 0, acceleration is 0. Omega t is equal to 0, acceleration is also 0. Here is the next one. When omega t is equal to pi by 2, acceleration is minus a omega square. We get point here like this. When omega t is equal to pi, we get acceleration 0. The point is here. See here, the graph is like this. The next point definitely will come like this. The graph is like this. The next point definitely will come like this. The next point definitely come will like this. Like this. This is the point. The next point is here. So in this way, the graph will come is like this. See here. The graph will come like this. Like this. Oh, very good. This is the graph. So in this way, we have easily prepared comfortably observation table, and from observation table we have prepared graph. We have prepared at first equation of displacement, velocity and acceleration, and from that equations we have prepared observation table. How observation table we have prepared? Let us watch the video again and again, and let us draw the graph by making use of observation table that I have also very carefully explain to you how to draw a graph. Okay, and from the graph now we have to draw the remarks, or we can say that conclusions. So what conclusions are getting from the graph? So see here, we can write here conclusions. We will write here, see, remark, or we can say that conclusion. What conclusion we got? Number one, the first conclusion we got is all the curves are periodic in function. That is, displacement time curve, velocity time curve and acceleration time curve are periodic in functions. What is meant by periodic in functions? Because all the curves repeat itself after a phase 2 pi. See here, one oscillation coming from 2 pi, second oscillation starts. See here, this is the first oscillation, and from 2 pi second oscillation starts. From this, like this is one oscillation, and from the 2 pi second oscillation starts. See here, this is the first oscillation up to 2 pi. So every curve repeat itself after a phase of 2 pi. We will write these two conclusions at first. We will write here. Number one, we will say displacement time curve. Next one, velocity time curve and acceleration time curve are periodic in nature. Number two, all the curves repeat itself after a phase interval 2 pi radian. After a phase interval 2 pi radian. What is the third conclusion? The curve, let us remember, the curve which starts from origin, we call it as sine curve. Which curve starts from origin? Two curves, displacement time curve and acceleration time curve. Both the curves starts from origin. So displacement time curve and acceleration time curves are sine curves, while velocity curve starts from extreme position, positive extreme position or negative extreme position. If they starts from positive extreme or negative extreme, that curves we call it as cosine curve. Another best result we see here. In the displacement formula, sine function appears, so it is sine curve. In the acceleration formula, sine function appears, so acceleration curve is sine curve. But here, what is about velocity? In velocity, cos function is appearing, so velocity time curve is cosine curve. So we can write here. What we write? Displacement time curve and displacement time curve and acceleration time curve are sine curves, while velocity time curve is cosine curve. So we will write another three conclusions after taking a screenshot of the board. So let us take a screenshot at first and then we'll proceed further. Let us take a screenshot. Let us take a screenshot. Let us take a screenshot. Okay. Then I will remove these three remarks and we have to see the fourth remark. What is the fourth remark? See here. What is the phase difference between displacement and velocity? See here. Displacement touches the axis at pi, while velocity touches the axis at pi by 2. So what is the difference between pi by 2 and pi? Pi and pi by 2. Pi minus pi by 2, we get pi by 2. Then now, phase difference between velocity and acceleration. See here, velocity touches the x-axis at first pi by 2, while acceleration touches the x-axis at first pi. So again, difference between pi by 2 and pi is pi by 2. So phase difference between displacement and velocity and acceleration is pi by 2. Is pi by 2. How we get pi by 2? I will repeat again. Displacement first touches the x-axis at pi. Velocity first touches the x-axis at pi by 2. What is the difference between pi and pi by 2? Difference between pi minus pi by 2. We get pi by 2. Then comparing velocity and acceleration. Velocity touches at first pi by 2. Acceleration touches at first pi. So what is the difference between 2? Pi minus pi by 2. We get pi by 2. So phase difference between displacement velocity curve and velocity acceleration curve is pi by 2. So what is the phase difference between displacement and acceleration? See here, these two graphs are exactly opposite. Exactly opposite. Here is crest, here is trough. Here is trough, here is crest. Here is crest, here is trough. So both the curves are exactly opposite to each other. They are in opposite phase, and when they are in opposite phase, phase difference between such a two curves is pi radian. So these are the three conclusions now we will have to write. See here, conclusion number 4. Phase difference between displacement velocity curve, displacement velocity curve is pi by 2. Then 5, phase difference between velocity acceleration curve, velocity acceleration curve is pi by 2. And last conclusion, phase difference between what? Displacement acceleration curve, displacement acceleration curve is pi. Of course, radian is here, radian. In this way, these are the 6 conclusions we comfortably write by making use of nature of graph. So this is all about graphical representation of SHM when particle starts from main position. So in the next lecture we have to see graphical representation of SHM, case number 2, when particle starts from extreme position. Till we will stop here and again meet for the next lecture. Okay, goodbye.